So in terms of Western Australia, we're in a drying climate. So having our farming systems protect themselves from drought by becoming more resilient is really, really important. So our smart sprays are focused at trying to harness rainfall by moving water from the interrows into the furrows, and in doing so, increasing productivity by allowing the plant to capture more water, more rainfall, and turn that into a product. We've been very focused in the laboratory and in the glasshouse. In essence, we've been looking at testing the smart sprays for their functionality and just checking what they're going to really do in terms of their contact with the soil and how they interact with plants. One of the challenges from a research perspective is thinking about how we scale up. There's so many million hectares of land that would benefit from these smart sprays. So we have to be very, very focused not only on formulations, but also on transport. How would you actually logistically get these smart sprays out to growers? And that's a real challenge and one that we've been working on. Within the Smart Spray project, it's being led by Murdoch University with funding through the Drought Hub, but also through WARC as a partner investor. So that's really, really encouraging that we've got two funding bodies seeing the importance of this work. But we also have industry partnerships, including EcoFar. And EcoFar is a small, medium enterprise, so a startup company that is building the precursors of the smart spray. And that's really important for us, that we can have that supply of the chemistry that goes into the smart sprays. Not only using industry partners, we're also working with Bangor University, which is a university in North Wales in the UK. And they have expertise in joining soil science and plant nutrition with plastics. And we're using a lot of their really high-tech facilities to understand how these plastics, these smart sprays, these biodegradable plastics, are performing when they come in contact with the soil. And our focus, of course, is making sure that these sprays are effective at water shedding, moving that rainfall into the furrow, but also that they're environmentally friendly. They don't leave any lasting legacy on land or in water. We're really interested in really understanding how efficient these smart sprays are in a real environment, so in a real field. So we will be running field trials this season up in the northern sector near Geraldton, in Merredin and in Esperance. And we're really looking forward to seeing what impact we can make on actual yield gain, because the proof obviously is in, can we increase productivity?
The liaison between the growers group and the farmers is very important. So the growers group provide the link between the scientists and the farmers. My role is actually to liaise with both the grower groups and the farmers to deliver the information from the lab into the field. We need to identify the barriers to adoption so that during our communication strategies on the new product, we cover any concerns well and truly before we market any new products. We need to understand what might stop somebody even trialing the product, never mind buying it. As part of the project, I spoke at a number of the field days, attempting to gauge farmers' response to the demonstration. We also conducted the survey. The overall response was that people were quite keen and interested in these new techniques. We made it quite clear that we're still in the early stages of development, but I had a lot of questions. People showed real interest. So based on that, we know we're on to something that could be taken aboard by a lot of people.
One of the things that we've really understood from speaking to farmers and growers about these smart sprays is how we functionalise them and give them added benefits. And one of the questions that keeps on coming up is about dust suppression. So can we help soil moving? So we're really interested in that. And also, can we use these smart sprays to protect herbicides? Because one of the problems with herbicides is they can move and become a problem to the seedling, but also UV damage of the herbicide decreases their efficiency. So we're really interested in that next phase of, now that we have the smart sprays, how do we add benefit to them and add extra value to the grower?
This particular Drought Hub project comes under the banner of an innovative technology or transformational technology. So if we get this right, we could potentially transform the agricultural space in the way that we harvest water.
So the Southwest WA Drought Hub provided us with that translational, that transformative funding to allow us to really put our theory into practice. So we're very grateful for their funding, along with the funding from WARC, because that gave us the cash, and at the end of the day we needed the cash to develop these polymers and to test them in the field.